Membrane switches probably means nothing to you, but chances are you use them or at least see them in use daily. Membrane switches are those soft touchpad buttons on the controls of many electrical and electronic devices. For example, the buttons on a microwave oven or on a cash register. The surface of the appliance control panel is called the graphic overlay. It's a sheet of plastic on which they print the design of the control buttons. Each button has a membrane switch underneath it. To make this graphic overlay, they first laser print a sheet of acetate film with the design, as many copies as will fit. They lay the film on a polyester screen coated with a light-sensitive chemical. Then, using this machine, they expose the screen to 2000 watts of ultraviolet light for up to 6 minutes. The light hardens the chemical on the parts of the screen that aren't shielded by the design on the acetate. This blocks the screen's minute holes everywhere except in the design. Workers remove the acetate film and rinse off the shielded chemicals that didn't harden. Now they have a screen stencil of the design they're going to print. Workers dry off the screen and install it on a printing press. A squeegee drags the ink across the screen, pushing it down through the open holes, printing the design onto the overlay plastic. Ultraviolet lamps cure the ink in a matter of seconds. Each colour of the design goes on separately. That means there isn't one printing screen for the entire graphic overlay, but rather a separate screen for each colour. Meanwhile, on another screen printing press, they print the circuitry layout onto transparent plastic. The ink contains silver, which conducts electricity. The circuitry layout will go behind the graphic overlay. Again, they print several at a time. Once the printing's done, it's time to assemble the layers that make up the membrane switch. First, the circuit layer goes onto an adhesive sheet. A roller ensures a solid, airtight bond. This spacer sheet will separate the overlay and circuit layer to prevent contact between the two from being continuous. Over each circuit goes a dome made of nickel-plated stainless steel. This forms an electrical contact that must be pressed to activate the circuit. They adhere a polyester sheet to hold the domes in place. After cutting out each circuitry layout and each graphic overlay, they expose the adhesive backing on the overlay and stick it to the circuit layer. The membrane switches are now complete. This control panel is for a hospital bed. Some membrane switches have a light-emitting diode, or LED, a tiny coloured light that goes on when you press the switch to confirm contact. The factory's robotic machines deposit 2 drops of epoxy paste on the circuit layer wherever an LED will go. The paste contains silver, again to conduct the current. A robot then picks up the LEDs and deposits them on the drops of paste. The robot places a dome on each circuit, creating an electrical contact. The red light you see is a camera checking the positioning. Testing equipment runs a current through the circuitry to make sure that everything works. Then a drop of transparent sealant goes over each LED. The sealant hardens under ultraviolet light, holding everything solidly in place. Now workers remove the panel from the automated line and plug it in. Lighting up all the LEDs helps them position the graphic overlay properly. This control panel is for an oven. No LEDs on this model, and instead of a dome behind each button, they print an electrical contact using the same conductive silver ink they use to print all the circuitry. After rolling on the graphic overlay, they peel off the protective plastic, then flip the control panel upside down and snap it onto its cover.